So we've got two more this afternoon. Need you guys to be respectful of our speaker and no more talking at the moment. Russell. So Gerald is up next. Wow, we've pushed this thesis along for a while, haven't we, Gerald? So glad to see. Test?
Definitely.
Definitely. Glad to see you're up here doing it today. He wants to thank everybody for coming, his parents, his panelists, Mr. Christian, Ms. Yasmin, and his advisor, Mr. Hans. All right. His title is How to Save Billions Before Everyone Dies, the Colonization and Terraforming of Mars. All right, Gerald, give me a couple of seconds, and I'll tell you when you can start. All right.
Two dots start at the top of an A4 paper. They both want to go down the A4 paper, but they can't go through the words. That would scramble them all over with ink. Therefore, the first one plans to go around the dots, while the other has a great plan. The other is going to go down by going up. But the other dot says, you can't go down by going up. And Columbus says he will go west to go east. Now, as we all know, Columbus didn't succeed in this. Columbus, indeed, didn't find China. However, he did find what the dot found. He found that the other side was full of a whole new continent of words. And that is the single most significant discovery of the 15th century. In fact, in history, most discoveries have come from nothing more than a leap of faith by a few men who believe in possibility. Now, colonizing Mars has enthralled science fiction since the 19th century. Telescopic studies of the late 1800s and early 1900s showed the existence of periodic polar ice caps on Mars, suggesting water, which was essential for life. The Mariner robots in the 1960s took pictures of the geography on Mars, and in 1976, they were able to prove frozen water was just below the surface, meaning everything was rich in carbon dioxide, offering potential for converting into oxygen or fuel through in situ resource utilization. A breakthrough came in 2015, revealing large deposits of near-surface ice, which meant a supply of water, production of breathable oxygen, and rocket fuel using electrolysis was very accessible. And in 2021, Ingenuity had a successful powered flight there, proving that it was possible to fly in the thin Martian atmosphere. It also brought the device named MOXIE to succeed in the extraction of life-sustaining oxygen. And this marked a milestone, the first time humanity was able to find life-sustaining resources on another planet. The collective recorded data accumulated from every era and generation serves as a cornerstone for the next phase, which in turn helped the next generation and the next. However, what would be necessary for this project? Well, Mars is similar to Earth. It is a planet with polar ice caps, large valleys. However, there's also liquid water under the surface and relatively similar days. However, it is more radioactive and colder than Earth. Currently, there seems to be no reliable energy source on Mars that humanity could immediately exploit, leaving explorers to have to bring their own energy. And the prominent choice seems to be nuclear energy. This is obvious because it provides power reliably and doesn't degrade in low light or heat. Mars' atmosphere is less dense than Earth's, yes. This leads habitats to have to be moistened and pressurized, meaning habitats will have round corners instead of actual corners. Also, habitats needs to be shielded with a thick layer of frozen CO2, which is easily accessible in Mars, obviously, and another thick layer of dirt would also help with the radiation. After ensuring energy, air, and preventing astronauts from getting cancer, there's also the issue of sustenance. While water is easy to come by, Mars soil is made of alkali and lacks the natural nitrogen properties of Earth soil. Therefore, they would need to be decontaminated. Aquaponics will be able to be used to raise fish and plants together. And there seems to be a consensus of prominent scientists in the field when discussing the concept of Mars colonization, a real plan being proofread and discussed by experts. But what is Mars colonization? what isn't it? Well, Mars colonization implies the installation of a permanent human-colonized community on Mars, while terraforming Mars is to make the planet fully inhabitable in the long run. This could be done by raising temperature and atmosphere, and in turn, allowing life to be sustained. Now, habitability is a measure of how much any environment can offer in the form of bare necessities of human habitation, such as access to water, clean air, stable environments, and friction forces. Whether or not Mars should be colonized is an issue consisting of three distinct ones that must be resolved in order. The first of which being, should we even leave Earth? The second of which being, should we even terraform, or should we find another planet that's suitable for life? And the third being Mars. Well, it would not be an exaggeration to say that the fate of the universe is at stake, because the fate of the universe is indeed at stake. If humans want to go down as the first society in all of history who wouldn't save itself because it just wasn't cost effective, then there would be no need to discuss this topic altogether. But otherwise, here it is. Mars colonization is estimated to take at best 25 years, with the premise that they are given the necessary funding and research. It would require a delicate process with proper equipment, needing money, proper experiments, needing money, and proper sample sizes, which also need money. Therefore, it requires a decision as fast as possible. If it turns out to be paramount and humanity decides too late, humanity is doomed. If it turns out to be entirely unfeasible and humanity also decides too late, we're doomed anyway. Therefore, Mars colonization and eventually terraforming should be a priority due to Earth's limits, colonization's practicality, and Mars's suitability. Now, Earth has been superb, undoubtedly. However, it is being exploited way too fast for the planet to regenerate. And in the end of the day, Mars terraforming should be considered because the Earth is limited. As of 2025, global tensions are exceptionally high, with multiple regions worldwide facing escalating conflicts and geopolitical instability. In fact, there are 110 ongoing armed conflicts worldwide. One day, someone in the world launches a nuclear missile. Everyone fires on all cylinders. There's now devastation, death, the loss of infrastructure. Radioactive fallout contaminates water, land, and food, and the EMP destroys all electrical systems. A nuclear winter comes, and ash is lofted into the atmosphere, blocking sunlight and therefore preventing any agriculture from happening. Therefore, cutting off the producer of every single food chain. Now, it's been found that the destruction of even 10% of industrial capacity will result in a decrease of 40% in the output of defense industries. However, in the event of a full-scale nuclear war, the devastation would be much wider, condemning global manufacture to cripple. Loss of professionals, researchers, educators. It would be a definite hard effect to all of society as we know it. And besides, the destruction of educational entities and research enterprises would mean that the knowledge humanity has accumulated over the last few millennia, poof. From previous examples, it is absolutely clear that such a catastrophe would take a long time to recover from. For instance, Japan and Germany took roughly a decade to recover after World War II. And this was after the strongest countries financially aiding them. Now, in the event of a nuclear war, or any catastrophe for that matter, this would not exist, because everyone would be overwhelmed, even feeding their own. Now, after this, Earth would be insufferable to live in. A nuclear war is actually not even necessary for this. It could be pandemics. It could be an asteroid impact. It could be a supervolcano eruption. It could be an alien invasion. Anything. It shows that the Earth is prone to being limited. And climate change could also happen. It is a strong sign that the planet's natural resources are limited, and happens because the planet cannot cope with the increasing effects of human impact. The atmosphere is limited in how much carbon dioxide and methane it can cope with. Otherwise, life starts to become completely unstable. This isn't just a message about climate. It shows us how Earth has set limits that cannot be ignored. The fact that the planet is still exploitable and that humans all over the world are still exploiting it does not mean this is not a serious problem. Now, just imagine if there were some kind of fail-safe to all these problems to minimize the damage. Well, whatever this failsafe is, it is imperative to safeguard the knowledge accumulated over the past few millennia for future generations. Some solutions have come out, such as the Svalbard Global Seed Vault or the Long Now Foundation. But seed vaults have no value if everyone who needs to use them are dead. Mars colonization with backups is considered an ultimate failsafe for civilizational survival. A strong case can be made to terraform another planet to resemble an ideal Earth. Pursuing this allows humans to start by producing new environments on Earth. Climate engineering, controlling the atmosphere, renewable power systems, and even self-sustaining supports can be used to help Earth thrive. And at present, Earth has to deal with many ecological issues, such as climate shortages or collapsing whole economy systems. And more effort towards terraforming would undoubtedly boost work on carbon capture, which means increased water reuse and the creation of biomes. Any ideas developed in space for astronauts would be quickly used and make a difference on Earth. So by preparing another world for habitation, consider investing in looking after the planet, starting with Earth. Besides, using this approach means humanity gets something seriously required: time to stall. Acting on globally and invent new ideas to support life, here or somewhere else in the universe. And because of this work, losses are avoided and communities can prepare for whatever unknown risk in the upcoming century. And when looking at survival through terraforming humanity, it also allows us to gain knowledge that allows us to thrive in unexpected locations. This new technology might enable humans to colonize anywhere in and beyond the solar system. Through astronomy, humans obtain new skills that let them develop unfruitful planets into rich habitats. Terraforming is valuable because it can be made and it will be made to fit different situations. No location would be too cold, no location would be too hot, and every location would not be too poisonous to shape. And terraforming takes away from the current biological factors that limit human life to a narrow range of conditions. Assuming only the planets in our solar system were terraformed, we would have near unlimited resources, and there will also be more room for a rapidly growing population. As opposed to expecting to find a natural habitat, humanity's attention should be on improving the habitability of those more feasible to reach. This innovation enables the making of safe habitats out of environments that people can't live in the present. For early development, spaces like Mars, featuring solid surfaces, similar gravity, and others are the best choices. Colonies that can change the environment allow for a long-lasting independence and do not need Earth's assistance all the time. Changes to planets also gives less importance to finding the best planet there, giving us more time to find the best locations to set up our colonies later. Terraforming is the best suitable solution rather than hoping for a place that already exists. The popular Christian argument that the Earth has been intended by an intelligent mind and will be to be habitable applies to all the planets. Life should exist on purpose, not by accident. Because it is unlikely that future students will have access to truly livable planets, terraforming ought to be regarded as the most basic strategy for space exploration. Because, for example, exoplanets, they're so far from Earth, such as Kepler 1240b. It is hard to imagine traveling there often or moving resources with present technology. After all this, the most popular planet among scientists who share this notion as of 2025 seem to be Mars, as it is the most logical option. While among planets in the solar system, Mars' similarities with Earth make it the most important target for terraforming. Since Mars possesses the most favorable natural conditions with technology, it is the best choice for long-term human settlement. To start, a day in Mars, 24.6 hours, is close enough to Earth's natural biological day that our sleep schedules would not be too affected. Mars is special because it also holds ice caps at its poles and water ice underground, all of which might be used for water, farming, or oxygen production. And unlike some inner planets and moons, Venus and other places like Europa or Titan, they present great difficulty. On Venus, the pressure is very high. In outer moons, it's covered by miles of ice, and they're way too far away from the sun to have intense, or way too far or way too close from the sun to have intense radiation exposure. None are as promising as Mars, because of how accessible, moist, and managing it is. As a result, it's the only planet in reach right now that could be the first target for terraforming. Because of the detailed research and technology developed from Mars, terraforming it is the most logical choice. Because Mars is the closest to Earth, outside of Venus due to the aforementioned issues, and promises a long-term future, it is the best planet for seeking human transformation. Traveling there takes, in best case, 6 months. Missions require less budget. It can happen more often. And support will be quicker, and communication will be clearer. Therefore, this means that emergency services will be able to be dispatched more often. For decades, organizations have devoted more effort to examining Mars than any other planet. Because of the detailed research and technology developed for Mars, we need to go. Terraforming Mars is the most logical choice. Many missions, such as the Spirit, the Opportunity, the Curiosity, the Perseverance, have collected information on the area, checked the soil, and identified water ice beneath the planet's surface, which is needed for life and energy. Besides all this, scientists are now creating technology suitable for Mars, including the ISRU, which allows future colonists to obtain water, produce fuel, and build from local resources. Again, there has been nowhere near this amount of preparation for any other planet. If the efforts were right now directed to another world, it would take way more decades to do the necessary research, design, and testing. However, despite the severity of the situation, the public is not yet at a consensus. Terraforming Mars is a priority because of two main schools of thought. The first, that disagree with this, believe in alternatives such as terraforming Earth, while the second thinks that the resources would be better spent addressing more urgent problems on Earth. Now, terraforming Earth back to Earth solution is about as effective as placing a band-aid on someone with a severe wound. Why? There's nothing wrong with placing a band-aid on someone with a severe wound. In fact, that is the first thing that should be done. However, notice how the band-aid is never the last solution, and there is always an operation following it. Terraforming Earth would be great, and it serves as a band-aid. However, it is only a stepping stone to terraforming Mars. While the other belief was that resources should be allocated for more urgent problems on Earth, since no immediate benefit might be reaped from sowing the seed on another planet. However, we should consider this decision as an investment that has very apparent high returns. And terraforming Mars means so many things. We could get breakthroughs in technology, sustainability, and planetary engineering. Energy and water management would not just result in making Mars habitable, but also serve Earth's environmental and resource predicament, and perhaps, in the best case, even help to make us a Type 1 planet. This makes Mars habitable, but solve Earth's environmental and resource predicament to perhaps make us even able to do more. To name just a few, the moon voyages accelerated the development of memory foams. It enabled scratch-resistant lenses, GPS systems, frozen foods, fireproof fabrics, and life support systems. It kickstarted industries and brought jobs. Who's to say that a repeat of this is unlikely through our terraforming and colonization of Mars? Throughout this thesis, we have discussed reasons and ways the government should consider to make this prospect of Mars colonization a reality by discussing Earth's limits, discussing terraforming or finding a readily suitable planet, to discussing Mars's colonization. As already aforementioned, this project would light up the road to terraforming all the astral bodies, leaving us with unprecedented resources, experience, technology, and falling to the conclusion that making Mars colonization and eventually terraforming a priority is the way to go. What's the alternative? Well, we could sit back and enjoy. We could accept that humanity's story ends right where it begins, at a piece of fragility, on a single planet, at the risk of disorder of opportunity. Remember your younger selves, turning their heads upwards at what could have been, dreaming sorrowfully as you looked to the sky as the world caved in, wondering why the people before you never took a shot. Next, envision our children, our grandchildren, or theirs even, turning their heads upwards at what could have been, dreaming sorrowfully as they look at the sky as the world caves in, wondering why we never took a shot. As their planet deteriorates in the face of Earth's deterioration. Now is the time to commit to bold, forward-thinking efforts that will extend human life beyond Earth. This project may not be finished in the first 100 days, nor will it be finished in the first 1,000 days, nor perhaps in the lifetime of this planet. But let us begin.
All right, thank you, Gerald. Our panelists today are Mr. Christian and Ms. Yasmin. Ms. Yasmin will go first.
All right. All right. Thank you, Gerald, for the presentation. Well, your presentation and then your paper from beginning is like really ambitious and really optimistic and pessimistic in the same way. So I'm just going to ask like two questions. The first one is your view of the terraforming Mars is kind of like optimistic. You mentioned a bit about funding. But you compare the state of the Earth like band 8 now, and then later on, need surgery. But I would like to see your, what you have in mind about terraforming Mars, because for me personally, you're comparing the state of the Earth right now is like band 8 to surgery, correct me? Operation? No?
That's the comparison of terraforming Earth right now, not exactly the Earth right now, but pretty much.
Yeah, but if let's say there are so many problems right now on Earth, so maybe we start focusing on like starting a new project on Mars. But it's like how do you know that we can, as community, as humanity, can have like one say or one voice? Because now even like handling global issue like climate change, we cannot even take care of our atmosphere. But it means in Mars, you have to create new atmosphere. Because later on, if let's say we actually succeed to go there, our descendant is not going to have like a safe life. Same thing like Christopher Columbus, Jamestown, there will be so many new challenges that we cannot even solve on Earth, and then you want to move it on Mars. Yeah. So the question is, what you have in mind until you are really optimistic that this is kind of like a good plan to start to pursue wholeheartedly, other than other plans on what's happening on Earth right now. Yeah, thank you.
Thank you. So to reaffirm your question, you're pretty much arguing that some may harbor the belief that resources should be allocated on more urgent problems on Earth. All right, thank you. Thank you for the question. Well, as I've previously said, but I probably didn't explain more on it, terraforming Mars it appears inefficient, and we can see it more of a investment of sorts. And although I do agree with you completely that it's true, Earth will not be able to gain immediate results from terraforming Mars, and we do still have issues right now. However, I believe that, objectively, the Earth will eventually, it is limited. The Earth is limited. And I do understand your sentiment of focusing on Earth issues first. However, I do believe that when Kennedy sent a man on the moon all the way back in the space race, America wasn't perfect either. And I do believe that his courage to opt to make that decision did do a lot for us. For example, as I've previously said, some examples are GPS systems, frozen foods, fireproof fabrics, and even miniaturized computers they all came from that gamble. So I guess to conclude, what I'm basically saying is we need to take a risk.
All right, thank you, Gerald. Okay, so that's a good statement. Yeah, we need to take risks. Yeah, as a human being, we have ratio. I think we need to take risks every single time. I think so. The second question is this: so you have stated that our technological advancements is because we take risks, but before the risks actually there is like chaos. Though there is war. Every technology that maybe we experience right now, that's because the fruit of war. So there is like cost behind it because of our sinful nature. I think God is really, really graceful to us. So from our destruction, there is still fruits of human labor from human ratio. So I would like to ask then, the earth is something that God gave it to us. So, and then we still are thinking about conquering exoplanet too. So take a risk in this case, like Mars could be our stepping stone, correct? Yeah, and then after that, maybe we can invade or kind of like conquer other places too. But I would like to ask then, in the Bible, what do you think about? Do you think that the Bible provides any guidance or principle? Like, is it conquering Mars is part of conquer a fruit and being being
Fruitful and
multiply
multiply the
and then fruitful? Is it part of it or is just limited on Earth? Yeah, thank you very much. I think that's the last question. Thank you.
Thank you for the question. This was actually a major concern of mine all the way in the beginning of the year, and I had to really consult with Mr. Bram for this, but I do know the answer now at least. And the reasoning is, the Bible does say, multiply and fill the earth, or be fruitful and fill the earth. However, according to the pulpit commentary, which is a commentary made by a very famous 17th century or 16th century evangelist, this is not a set in stone ban. As in, for example, God said, multiply and fill the earth. Does that imply that when a woman is barren and cannot have children, she's going to go to hell? I hope not. And there's also the argument that, you may eat off any fruit in this garden, God said to Adam and Eve. But if Adam and Eve didn't eat from one of the fruits, I don't believe that he would punish them. So my conclusion is that, according to pulpit at least, is more of a God giving us permission to multiply and fill the earth. It's not a ban to say, you must stay on the earth. Although I do understand why it may seem that way, because I also first thought that before. Thank you for the question.
All right, thank you, Ms. Yasmin. Mr. Christian?
Hello, Gerald.
Hello, Mr.
Okay. Yes. Okay. So thank you for your presentation. This is quite a bold topic and quite it's an out of the ordinary topic, although it is technically very highly debatable and intensely discussed in the scientific community, especially for those that are working as an astronomer or has interest in exploring this space.
Right.
Okay. Now, all right, let's start with the questions first, but I do have to maybe also ask Mr. Wade about this technicality. I'm looking at your thesis that you submitted this morning.
Yes.
I don't see a works cited at all.
About that. I was planning to add would you like me to cite you a direct source from anything?
Can you maybe give a few examples?
Well, some of my most major sources include NASA. I also looked through some news documents, majorly about Mars and the like, probably some from New York Times, I remember. And another one of my main sources was Kurzgesagt, which a physics teacher of mine recommended to me.
That's me.
It is, yeah, that's true.
Yeah.
I would say those are my three main sources.
Okay, all right. So if that's the case, then I am going to ask about those details for that context. All right, and yeah, you definitely should probably make sure that it's present in the actual work in the future, because this is, of course, again, a very difficult topic to handle, and without mentioning any of the sources, that's basically a dangerous oversight. Yeah. Okay. Right. On to the questions then. All right. Now, let's see. Okay. Right. Now, your whole discussion here is that, it's going to take a lot of effort and a lot of considerations that in order to be able to make Mars, at least, inhabitable and sustainable in the future, right? And you also mentioned the fact that Mars itself is, it's the best choice and the ideal choice because it's very similar to Earth. But if we're being really honest about all of the details, Mars does have quite a few differences. Well, maybe not a few, it's like quite a good amount of differences that basically cause it to end up becoming what it is at the moment instead of thriving of life like Earth, right? So maybe could you elaborate further how many things we have to change or how many things do we have to maintain on Mars by the terraforming process in order to even have it begin developing an ecosystem or a life as complex as Earth's?
Thank you for the question. I believe that if you'd like a very sophisticated answer on this, it's more of in my facts and definition section, where in the paper at least, where I think I more thoroughly at least explained this. But if you'd like an answer now, some of the things that we have to do include finding our own energy source, because at the moment, Mars has no very prominent energy sources. We could use solar power, but then Mars travels in a weird, what do you call it? Weird axis, so it's not always consistent, and there's lots of clouds. We could use wind turbines, but there's not enough wind on Mars, and it's not reliable. So the best source of energy is nuclear. Other than that, there's also the issue of food and water. And to solve that, the leading agreement at the moment is that, water is easily accessible due to the polar ice caps between 0 and 60 degrees. But the food would, again, require us to decontaminate the soil first because they lack nitrogen and they have too much alkali, if I'm not mistaken. And that would only be agriculture. And for the fish, for the protein or other nutrients for that fact, we could theoretically use aquaponics, or at least that's what Kurzgesagt did believe in.
Right. I think you did overlook a little bit of another detail. The fact that, you mentioned it about the issue that Mars has radiation piercing through its atmosphere because, in one case, do you know what is protecting the Earth from the radiation from the Earth? Sorry, from the radiation of the sun, my bad. Yeah.
I would have to say that I think, to my belief, the thing protecting the Earth from the UV rays of the sun being too dangerous would be the atmosphere.
Not just the atmosphere, there's one more thing. Have you researched about it at all?
I see.
Do you need a hint?
Does it start with G?
No.
That's unfortunate.
This is related to a lesson that I taught you in this grade, actually. It's the magnetic field of the Earth, which is caused by the movement of the Earth's core, molten core, the magma. Right? So that's literally the only reason why Earth is spared from the bombardment of intense radiation that kills off planets, but Mars does not. Because in that issue, Mars' core is pretty much stagnant in comparison. That's why it's basically wiped away all the atmosphere from the past. And perhaps that's also another big consideration as part of your sources I've mentioned. So yeah, you probably could also put that in your detail of the issues and challenges that have to be faced. Because let's be honest, I mean, a planet where you have radiation continuously poisoning and causing accelerated cancer and everything else with it is very much not really what you call sustainable, isn't it?
At the moment, I would agree.
Yeah, okay. All right, let's maybe go to a different question for now, yeah?
Right.
Now, another basic, if we're talking about the developments and the advancements of space technology, yes, we have come up to quite a long way with the Hubble telescope, with the multiple satellites and probes and everything else that we have sent all the way, perhaps even to the edges of our solar system so far, right? But the usual and very blatant issue about sending them is, the Earth's gravity is rather powerful, so we require a huge amount of fuel and a huge amount of energy and power just to be able to launch practically a small compartment or a small probe at most, right? And that's pretty much what is, keeping us back from being able to just leave Earth and explore the space with ease. This affects everything up to the design of rockets in the first place, where, pretty much you have a small compartment on the top that is intended to go into space, and then everything else is literally just for it to escape the Earth's gravitational pull. So is there any solution for this matter? Or is there any ideas on how to overcome this? Because, well, if you want to establish a colony on Mars, then you're going to have to be able to send something more like than a small office's worth of material and resources. Don't we think? Yeah.
That's true.
Do you have any?
All right.
Is there any way that this can be tackled?
Well, as you've previously just pointed out, it takes a lot of fuel to even send a small compartment to Mars. And that really goes to show, first, how long it would take to actually make a Mars colony. Even the most optimistic scientists believe 25 years, at least. And they would really have to go there slowly, and it's a really long process. But I don't think that exactly leaving Earth is being able to make rockets that leave Earth is our main issue. And I'm sure you'd agree, because we've been able to do it. I'm not cheaply, but we have been able to do it. And if the main concern is fuel, am I correct in understanding that the main concern is fuel?
Well, those challenges again about the rocket design and everything.
Right. Well, rocket designs are being made right now. They're not perfect, obviously. Sorry, they're not perfect. And may I tackle the fuel issue first?
Yeah, go ahead.
Right now, there's not a lot of fuel, and going to Mars is expensive. Next year, there's going to be even less. Next year, there's going to be even less fuel, and less fuel, and less fuel. And the main fear is that, again, if we do decide too late, it's going to be there's really nothing else to do. And I understand that there's the sentiment that going to Mars or out of planet anywhere really would cost a lot of fuel. But I feel like now, where we have the best mining capabilities we've had in a long time and the best ability to extract resources from Earth in a long time, so we're right. How do I explain this? We're just civilized enough in our civilization that we're able to extract resources from the ground well, but we're just not too late for those resources to be completely exhausted. I guess that would be my answer.
Okay. Well, I was actually asking that because there is actually a detail that at least one of the sources that is mentioned stated that is perhaps a nice stepping stone compared to just sending it directly from Earth, which is, well, to make a base on the moon. Yeah, there you go. I was kind of hoping that you
I
elaborate on
apologize.
that. But I mean, it is still all ideas and theories at the moment, right? So it's not, yeah, it's still quite a big dream for any of us to come up with. But yeah, ideally, it's probably a lot easier to first establish a mining colony on the moon, use its resources, and then perhaps use it to aid the colonization of Mars. So that's also like a supporting argument for you, maybe. All right?
Thank you.
Okay, so maybe let's go to the practicalities of this, right? Okay, let's imagine that we do manage, or like humanity manages to scramble together and finally start the steps to terraform Mars and also starts to make it sustainable and inhabitable, right? So now we have colonies of Earth and Mars at the same time, right? Would there be any issues or differences between people who are born and living on Earth compared to Mars in general?
Am I correct in assuming you mean biologically?
Biologically and other factors, socially, maybe. There's a lot of factors, right? Maybe, could there be any?
Well, I think there's definitely a difference because we analyze Russians who are born in a certain geographic situation, and we analyze, for example, let's say Indonesians who are born in another geographic situation. Even Russians and Indonesians are going to have differences due to their location. And I think that difference will only be amplified between Earth inhabitants and Mars inhabitants.
Okay, yeah, and
We're
that's
almost out of time.
okay.
Okay, can I ask, let me get one question in there. So how do you see this thing working? As a global effort, or do you see it as, like, for example, you may not know this. I'm an old man. Did you know that? I actually stood on a Florida beach and watched Apollo 11 take off with binoculars, and then made it home in time to see the video of Neil Armstrong walk off the lunar module onto the planet, onto the moon surface. So anyway, the point is that what really pushed that thing along, the space race, was a space race. It was competition between the countries. It almost seems like if we're going to look at leaving the Earth, maybe it needs cooperation, or does it need competition? How is that going to be fueled along? You know what I'm asking?
Okay, thank you for the question. Well, all right, so which would be more effective, competition or cooperation? Well, of course, the sweet spot would be a mix of both, because competition, complete competition, would mean constant sabotaging, constant attacks, constant everything. While complete cooperation, I would say it's more promising than complete competition. However, I do believe that the sweet spot is just somewhere in between, because humans are known to have been very competitive in history. Be it right now, there's 110 global wars happening, be it the trade war, be it some Israel war, everything. And yeah, I do believe it's the sweet spot between it.
Okay, we are out of time. Thank you, Gerald. Okay, we're gonna, Gerald and friends and family, panelist and advisor over here, we're gonna meet for just a couple of seconds, take some photos, and then we're gonna start with our last presentation of the day.